Andrea, are we going to that? Yes.
All right. So welcome, everyone. Thank you for taking the time out of your day to come and see me present today. I'm super excited to talk about this. It's getting started with data modeling, and I am Angela Henry. And quick bit about myself. I am in High Point, North Carolina. I am not a North Carolinian native. I don't talk funny like the folks here do. I've lived all over the US, but right now I've been in High Point for almost 15 years now. So, but prior to living in North Carolina, I lived in Denver, Colorado for 15 years. And prior to that, it was all over. So anyway, so I probably talk funny, but not like they talk funny here. So funny, haha, I'm not sure. I'm sure that's what they think when they hear me talk here. Anyway, I am a solution architect at Blue Granite. Blue Granite is a company that specializes in business intelligence and modern analytics. And we're a Microsoft partner, a gold partner. So we do a lot of work in conjunction with Microsoft and helping people get started with stuff. I am a data platform MVP. I'm also a Microsoft certified trainer. And as Andrea said, I do have a Twitter handle. It's SQL Swimmer. And as you can see by that picture, not only am I a swimmer, but I'm also a coach and an instructor. And I'm going to get my soapbox out here for the next 20 seconds and say, if you don't know how to swim, please learn. It is the only sport that can literally save your life. And if you think as an adult that you can't learn to swim, you are absolutely incorrect, because there are instructors like myself who are specially trained through US Masters to teach adults how to swim, because it's very different than teaching children how to swim. But I do also teach children how to swim, and I do also coach a seasonal age group team. So I do also teach very small children how to swim, like as young as 3 years old. So if I get to start talking too fast, just kind of say, whoa, 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 slow down. My lips aren't blue. You don't have to talk so fast. So, because when their lips turn blue, they're not listening anymore. So, all right. So now that you know a little bit about me, I want to know a little bit about you, because we're not in person anymore. So I can't see your bright, shiny faces. So I want to know, are you a developer? Are you a DBA? Are you an analyst? Are you something I didn't list? Are you like an IT manager? Or are you just getting started? All of that. And feel free to just pop it in the chat there. And I'll see what pops up. We got an engineer. We got a DBA. And while people are doing that, I'll give you a little bit of background on how I became a solution architect. I started out in IT more than 25 years ago, back before the internet was a thing. I was an application developer, and I was creating client server applications. So again, before the internet was a thing. And then I moved into the role as a DBA, focused mainly on SQL Server. I did a little bit of Oracle work, but I decided I did not like that at all. So I stuck with the Microsoft stack. And then about 10 years ago, moved into more of the BI developer type role. And I am now a solution architect with Blue Granite. So that's kind of how I came to be where I am today. So we've got all kinds of things, some engineers, some consultants, developers. Awesome. Cool. All right. So what are we going to talk about today? Well, we're going to define what data modeling is. We're going to talk about the different benefits that you can get from data modeling. And then we're going to talk about how you're going to get started with data modeling. But before we do that, it's selfie time. Now, if you've ever seen me present in person, I always like to take a picture of myself with my class. But since we can't be in person, I take a picture of myself presenting on my computer, and then I put it on Twitter, because, you know, nothing happens in real life unless you put it on social media. So here it goes. I'm going to take my picture. I got to get my camera up. Should have been a little bit more prepared. Turn this around. Right. And now I got to put this out on social media. So bear with me for just a quick second. And I'm going to put that out there. And there it goes. All right. Now it's happening for real because it's out on Twitter. So let's keep going. All right. Oh, and for those of you, my lovely hat, this is my favorite hat to wear when I present virtually. It tends to lighten the load. My older sister is a preschool teacher, and she says that if you make learning fun, you will remember what you learn. So I'm trying to make learning fun. So defining what data modeling is. Well, we're going to start with a little bit of database history, kind of a history lesson here. First we had navigational databases, then we moved to relational databases, and now we have analytical databases. So when we look at those navigational databases, these are the kind of the original ones that were really developed kind of back in the 60s. And it was manual navigation with linked data sets in really large networks. So think COBOL, for those of you who are old enough to know what COBOL is. So those were navigational databases. And those were not super performant. They wasted a lot of space. And if anybody knows anything about COBOL, every single byte was precious because they stored repeating values everywhere. So they tried to shorten everything that they possibly could. Well, then came relational databases. And this came about because of those limitations and those performance issues with navigational databases. So f.k.a. back in the 70s, he worked for IBM. And he said that we can't do that anymore. We gotta not store all these repeating values. We need to normalize our databases. So we want to kind of separate it out so that we are not storing repeating values. So we're going to normalize this data. And because we don't want to have those performance issues, we want to design it so that it's very highly transactional friendly. And we're going to use this language called SQL, structured query language, in order to be able to pull that data out of our relational database. And we need to optimize it for write operations, because these are highly transactional systems. So think of things like point of sale systems or credit card processing. They have to happen at a super high transaction rate. So that's where your relational databases come in, and they enable all of that activity to happen. Well, relational databases, those are super cool and they do a really good job, but have you ever tried to write a report off of a relational database? That gets really hard, takes a lot of SQL skills, and they can get really complicated. So that's where they came up with analytical databases. And they said, you know what? We don't care. Storage is cheap now. We can store all those repeating values. And one of the reasons that we can do that is because we have these great columnar engines out there now. So let's go ahead and let's denormalize that database. Let's go ahead and store all those repeating values. And because this is an analytical database and not the transactional database, those the data is loaded in batches. And typically it can be hourly, daily, weekly, monthly, but it's not as the transactions happen. They're batched up and then they're loaded. So think of like a data warehouse. And then what happens is those analytical databases typically have a semantic layer that can be put on top of them. And then you use the analytical languages like MDX or DAX to be able to pull that data out. And these are optimized for read operations. So think of this as like your reporting solution. We want to be able to get the data out super fast. We don't care about writing because we're not writing anything. We want to get that out as fast as we can. Nobody wants to sit there for 5 minutes and wait for a report to come out. So those are your analytical databases. Now, when we talk about data modeling, the two most common use cases are either for transactional databases or for analytical databases. And what we're going to talk about today is the data modeling use case for analytical databases. And when we do that, that is actually called dimensional modeling. And you'll find out why we call it dimensional modeling in just a few minutes when we get into some of the more details that we've got going on. So when we talk about dimensional models, there are two methodologies that are out there, and this can be a very dividing philosophy for some folks. You know, if people are willing to die on their hill, whether it's Inman or whether it's Kimball. I prefer to think of this as, do you mix chocolate and peanut butter, or do you not mix chocolate and peanut butter? And just so you know, I'm all for the Reese's peanut butter cup. Mix them. Fabulous. So when we talk about the Inman method is a top-down approach, because you look at the entire organization and then you design around that. And it really has that entity, and it's relationship oriented, and it's more normalized. It's not as normalized as a typical relational database, but it's much more normalized than the Kimball methodology. When we talk about the Kimball methodology, that's a bottom-up approach. Instead of looking at the entire organization and trying to design for that, you look at the individual business processes. You start business process oriented and you go from there. Instead of looking at the entire organization, start with the business process and build out from there. And that is denormalized. And it's a lot less complex when you have to create those read operations against your database. So if you're going to be using any of the Microsoft tools, analytical tools, the Kimball methodology is what is best, because that is what those tools were designed to work with. So that is what we're going to be talking about. And the focus of this session today is the Kimball methodology, and that is referred to as dimensional modeling. So vocabulary. With any new technology, you always have new vocabulary that you have to learn. So, dimensional modeling is no different. So when we talk about the Kimball method, we're going to have facts, we're going to have dimensions, we're going to have a star schema. We'll talk about granularity. We're going to have surrogate keys, and we're going to have Sentinel values. So those are the big vocabulary items that we need to define and talk about when we talk about dimensional modeling. So let's start with the facts. The facts are typically going to be our long, skinny tables. So they don't have a whole lot of columns in them, but they typically have, millions, tens of millions, even billions of rows in them. These are what our business processes are modeled upon. When you figure out what business process you want to model, that's essentially going to become your fact table. Now, there can be different kinds of facts out there. You can have additive facts. So these can be summed across all of your dimensions, and we'll talk about dimensions in a second, that are associated with that fact table. So something like a sales amount. If you're collecting daily sales, that is fully additive. You can add those all together. Another kind is the semi-additive. And this means that you can sum across some of the dimensions, but not all of the dimensions. So think when you're trying to, like the balance on your checking account, you have a balance amount that goes through there. You don't want to sum the balance amounts, because you'd have like $1 billion in your account if you sum the balances. I would like that. I don't think the bank would though. So that's a semi-additive when you're looking at things like balances like that. You have non-additive facts. So these are things like ratios or percentages. It doesn't make any sense to add ratios or percentages together. That doesn't really mean anything. And it's always better to store the values that compute those ratios than it is to store the actual ratios. But sometimes you have no option to do that. You just have to store the ratio or the percent. So those are non-additive facts. And the last one that we have are factless facts. Now, these are things where you're just trying to record something that happened. So it's really what it is. It's the records are all your dimensional entities are coming together at a moment in time. So think about you're trying to track attendance at school. there's not really anything to do other than to count the fact that that student showed up. That's it. That's all you're trying to do. So that would be like a factless fact. Dimensions. Dimensions are our short fact tables. So they typically have a lot of columns, which are called attributes, but not a whole lot of rows. And those attributes are what we use to slice our facts. So I want to see my sales by date, by salesperson, by plant, by store. Anything that follows the word by, that's typically going to be your dimension. Those are the things that describe and you want to slice and dice by. So those are your dimensions. Now, of course, there are different kinds of dimensions. You have conformed dimensions. So when we looked at the Inman model, that looked at the whole big organization and you designed for that. But with the Kimball methodology, you start with a single business process. And then when you get that modeled, then you go to the next business process. Well, dimensions that can be applied to multiple business processes are conformed dimensions because they can be used across or typically throughout the entire organization for all business processes. So think of things like employees or dates or what's another good one? Customers. Typically, those are, the same across every business process within an organization. So those are conformed dimensions. Then we have degenerate dimensions. This word just makes me laugh because it's like, really? That's seriously, that's what it's called. So a degenerate dimension is defined when it has no context except for its primary key, other than just it exists. So the example I like to use here is when we talk about invoices. When you have an invoice, you typically have multiple lines on an invoice. So when we model this process out, we're trying to, break it out so that we have all of those attributes of our invoice. And typically, everything from the invoice will apply to the line except for the actual item that we're purchasing with the price and the quantity and all that. So when you look at it, all that's left is basically the invoice number. And that's important, but we don't really have anything that we want to count about the actual invoice number itself, other than we want to be able to know what it is. So in that case, we don't want to create a dimension just for the invoice number. So we're going to put it on the fact table and we're going to count it as an attribute. And then when we put that attribute on our fact table, that's when we call it a degenerate dimension, because that dimension lives within the fact table. And that's why they call it a degenerate dimension. The name is just weird. I don't know. Sometimes it gives me the heebie-jeebies. Sometimes it makes me laugh. It's a degenerate dimension. All right. And then we have junk dimensions. So this is actually exactly what it sounds like. So how many people out there have a junk drawer at home? Like in the kitchen? Yeah, everybody's got a junk drawer. That's basically what a junk dimension is. You have these kind of onesie twosie things that you're not sure exactly what to do with. So you just kind of shove them in the junk drawer, right? Same with the junk dimension. You have these single attributes that don't really have anything to do with anything else. So what you do is you combine them together kind of in a Cartesian product format. So you match them up so that you have all the possible combinations. And then you create a dimension out of that. And when you do that, that's called a junk dimension. So we've got junk dimensions. And lastly, we have slowly changing dimensions. Now, customer was one of the examples that I used for a dimension. Well, do we care if a customer moves? Well, sometimes we might. If we're a newspaper delivery place, we may need to know what their old address was. If we are selling something, that we don't care that they've moved, we just need to make sure we have their current address, then we don't care. So slowly changing, what that's referring to is, are we tracking the history of any changes that happen to that dimension or to that customer? Do we need to keep track of that history? So that's what slowly changing dimensions are referring to. And you can have, there are varying degrees of changing dimensions. So just know that when somebody talks about a slowly changing dimension, there are additional types that are probably a little bit more in depth for the conversation today, but there are multiple types of changing dimensions out there. So those are our dimensions. Now we have our star schema. And the reason that we call this a star schema is that we have our fact table. So that's our business process. And then we have our dimensions that describe our facts. And we relate those dimensions to our facts. And when we lay it out, it looks like a star schema. So that's why they call it a star schema. And just for added effect, this is the ultimate star schema. The head of that dandelion is the fact, and all those little seed pods, think of those as your dimensions. The seed pods don't talk to each other, they only talk to the head of that dandelion. So that's, to me, the ultimate star schema. All right, and now we talk about granularity. And granularity is probably like the most important thing, because granularity defines what exactly a single row in our fact table is going to contain. And you have to define your grain before you do anything else. If you start trying to model your business process without defining what your granularity is, you're going to have to go back and rework your design. I guarantee you. You know, that's never happened to me, but it'll probably happen to you. Just saying. So you want to do it before you do anything else. And you want to try and get to the lowest level possible. And when I talk about that, when we talk about trying to track something over time, do we want to track it by the year? Do we want to track it by the quarter, by the month, by the week, by the day? I don't know. We need to get down to the lowest possible grain that we can in order to provide the most flexibility, because we can always roll stuff up, but we can't always unfold it once it's rolled up. So go for the lowest possible level there. And then the next thing is, don't mix granularities. Now, when I say this, I'm talking about within a specific fact table. You don't want to mix granularities within a specific fact table. You can have different fact tables that have different granularities, that's okay, but not within the same fact table. All right, and now surrogate keys. Surrogate keys, they have no inherent meaning, and it's really just a fancy way of saying we made it up. So it's, if you stop and think about Oracle, was that a sequence in Oracle, an identity column in SQL Server, an auto number in Access? It's that auto-generated number. It's an artificial value that allows you to uniquely identify records. That's all that is when we talk about surrogate keys. And it allows for that, those natural keys, if you're combining multiple systems of data together, to be able to maintain the natural keys from those other systems without having any conflicts. So those are our surrogate keys. And the last one on our list is Sentinel Values. And Sentinel Values are those default values of when we're missing data. And there are two different kinds of Sentinel Values that you can have. You can have unknown records in your dimension tables, or you can have Sentinel Values for attributes. So if you're looking at a customer and the last name is missing, do you want it to show up as blank, or do you want it to show as a unknown or NA or something like that? And that provides that consistency across your dimension for your data. And the other key thing here is agree upon these values with your business users before you use them. I can't tell you how many times I assumed they didn't want to see blank values, and I used a Sentinel value and they said, I never saw, how come we have so many people with the last name unknown? Okay, my bad. You wanted to know when they didn't have a last name. Got it. Okay, so agree upon that upfront on what those values will be. All right. So with that, that's all of our vocabulary, and we've defined what data modeling is. So do we have any questions about the vocabulary or anything that we've talked about so far? And I'm going to take a drink while I see if we've got any questions.
We just had a wish that those degenerative dimensions would just start behaving themselves. Sorry. I should not.
You almost got to see me shoot water out my nose. So that is a trick that I'm very famous for. But I really don't want to share that with everybody.
I put a link in the chat where you're describing like the Kimball method. They have a PDF, like the data warehouse toolkit.
Yes. In fact, right here within arm's reach is the Kimball book on the data warehouse toolkit. It's a series of books. They do have their own website that you can go out and check out. I highly recommend that if you want to get into data modeling, dimensional modeling. They sell them on Amazon, basically anywhere, but they do have their website where you can get a lot of that information for free. I just work better when I have a book that I can reach to. I guess I'm just old that way. And I do actually keep it right here on my desk within arm's reach, because there are sometimes when I come across a situation where I'm like, I have no idea how to model this because I've never done this before. And I crack open my Kimball book and we're going, oh yeah, look, there we go. Nice, Scott. Awesome. Yeah.
That's a first edition collector's item.
Yeah, I was gonna say that's amazing. Mine is, I've got the second edition. So nice.
I'm just gonna make one comment because this really tripped me up when I was first starting to figure out data modeling. All that dimension and fact stuff, those are all tables.
Yes.
Those are all tables in our relational database.
Yeah. Not in the relational database.
A database, SQL Server
Yes.
database.
In a database. That's what we want to do, is we want to model it out so that they become tables within whatever database we're going to use. And you can use SQL Server, you can use Oracle, you can use whatever database system you want. But it's those relationships that we'll talk about in a little bit that really come in key when we get there.
But this is the SQL Server users group. So the only database we use other than SQL Server is Sybase.
Okay. Very nice. Very nice. All right. Any other questions about defining our data model or those vocabulary words that we were defining? I don't see anything else in the chat, so I'm going to keep going. So let's talk about the benefits of data modeling. So first thing is flexibility. When you have a well-formed dimensional model, you can support different granularities. And I talked about this a little bit earlier. We don't want to have the different granularities in the same fact table, but we can have separate fact tables with different granularities. And if we have a well-formed dimensional model, we have ultimate flexibility in order to do that. And a really good example is that, sales versus budget or forecast. Sales are typically aggregated on a daily basis, but budget and forecast is usually done at the month level. So you don't want to add that data together in the same table, but you can have different fact tables, one for your sales, one for your budget. And your budget can be at a monthly grain level and your sales can be at a daily sales level. And then when you go to compare them, there are some things that you can do, but you have that flexibility because you have them separated out because they have different granularities. The other thing is it's a lot more intuitive than a typical relational database. One of the reasons is that because you're using the business vocabulary when you create this data model, and you're using friendly names. I don't know how many people in here have ever tried to crack open Microsoft's finance package. What was it called? Great Plains, where they use like letters and numbers for their table names that made absolutely no sense. And same with their columns. It's like, nobody can understand what that is. Use friendly names, define those column names for what they actually hold. It makes a lot less work when you try and build that semantic layer to go on top of your data model. And the keys are hidden. that's a really cool thing. Your business users don't care about the keys that make stuff unique. They just want their data to work. So you hide those keys from your business users. And then the last thing is that relationships only exist between facts and dimensions. We'll talk about a concept called snowflaking, which is when you have relationships between dimensions, which is something that you want to avoid if at all possible. So for the most part, relationships only exist between the dimension and the fact, not between dimensions. And you get faster processing. With that columnar engine out there, and you have all of those repeated values, it stores that value once, and then it stores a pointer to that value. So you get super high compression, and with that compression brings better performance. So it goes a lot faster. And the code that you have to write to pull this data out is so much more, it's a lot less complex. It's so much easier. So I've got a quick example. On the right or on the left-hand side, here's a very typical example. If you're trying to pull something out of a relational database, where I've got my use case here is kind of like the header detail. So invoice line number, and then trying to get all of the different attributes from a relational database. And when I count this here, I've got 1, 2, 3, 4, 5, 6, 7, 8 tables that I have to join together in order to get all of the information that I need. But if I've created a well-formed dimensional model, look at that. I've only got 2 tables I've got to join. I don't know about you guys, but I would much rather do this number on the right-hand side, only 2 tables, much easier. So it's a lot less complex when you have to query data out of it. So those are the benefits for data modeling. Questions out here. SAP, abbreviated German name for tables. Oh my God, I'm so glad I don't work in SAP. Ike. Ooh. Let's see, is there a maximum number of characters for a friendly name? I do not like to use abbreviations. That's my own personal best practice. So a lot of people will use like DT for date or AMT for amount. Spell it out. It's going to just make it a lot less ambiguous for your end user. Spell it out. To me, your maximum number of characters is only going to be limited by the system that you're using. So in SQL Server, what's that, 128 characters for a column name? Is that right? Does that sound right? I haven't been a DBA for a while, so.
That sounds right to me.
Okay. It's been a while. Yeah, so just follow your heart. Exactly. Name it for what it is. Be very concise. You don't have to be flowery with it, but to me, the really key thing there is don't use abbreviations because it's not going to save you anything. All right. So any other questions about benefits of data modeling? Yeah, the query is going to run faster if you use camel case. Exactly. Yeah. Fewer kittens die when you spell out words and then instead of using abbreviations too. That's just a little known fact. All right. So how do you get started with this? Well, look at this. This is something that a lot of DBA people and database developers are very, very used to seeing is this giant relational diagram. And you have to, pull something out of here and you're like, I don't even know where to start. So how do you get started? Well, we're following that Kimball methodology. So first we're going to select our business process. That's where we have to start. The next thing is we're going to declare our grain. So I said you have to declare the grain first. Well, you have to declare your business process first. Then you can declare your grain. So I kind of lied, but not really. So declare that grain. Next, identify your dimensions. How do you want to slice your data? What's the who, what, where, when, how, and why of how you want to see your data. And then identify the facts. Now the facts, we talked about those being tables, but the facts really, what they end up being is a table of measures. and those things that we want to measure about our business process. So let's take a little bit deeper dive. So selecting our business process. So this is that, again, that operational activity that we want to end up measuring, what we want to figure out. We want to analyze that business process. We want to declare our grain. So what will that single row in our fact table represent? It's going to be the sale of a product on a date to a customer in a store by a salesperson. So that's what, in our example, an individual single row in our fact table is going to represent. So now when we try to identify the dimensions, the customer ends up being who, our product ends up being what, the store is where, the date is when, and the salesperson is how. So the sale of a product on a date to a customer in a store by a salesperson. So we've got 5 dimensions. So we've identified our dimensions. Now let's talk about our facts. Remember, these are the things that we're trying to count or measure. So they're gonna be like kind of in the form of questions. So what are our sales? How many products did we sell? How many customers do we have? What's our sales margin? Those are the facts. Those are the things that we're trying to measure about our business process. Now we can put it all together. And when we do, we've got our sales table and we've got all of our keys in there and we've got our units sold. That's one of the things that we're going to try and measure. We've got our customer, we've got our product, we've got our store, we have our date, and we have our salesperson. And they all relate back to that sales table in the middle with their keys in the sales table, in that fact table. None of those dimensions are related to each other. So when we compare these two side by side, which one are you going to use? I'm going on the left. That looks a whole lot easier than what's on the right. Just saying. Just saying. So in the end, star schema all the things. Star schema all the things if you want to create a well-formed dimensional model. And what do you want to count? We want to count our sales, our widgets, our occurrences. Those are our facts. How do we want to count them? By date, by product, by customer, by store. Those are our dimensions. So really what it boils down to when you create that well-formed dimensional model is, what do you want to count? How do you want to count it? So that's it for, how you would go about doing that. Do we have any questions out there before I break off into my little bit about snowflaking? Let's see.
I have a question.
Sure.
How do you go about moving data from that big relational mess into a snowflake? Not a snowflake, but into a star schema?
I am so glad you asked. We are going to see a demo on that, but I usually start with my graph paper, and I don't know if you can see the actual grind, but it's grid paper. I am a pencil and paper kind of person, and I actually draw it out. And I have my fact table right here, and then I start by what I'm trying to measure and then the attributes that go in there. So that's honestly where I start.
I'm also thinking, like, do you use, say, linked servers in TLSQL? Do you use SSIS? Do you use replication?
So it's going to depend on what you're trying to, the data you're trying to combine, the data you're trying to analyze. So if you have multiple systems that you're trying to integrate together, you're going to have some kind of ETL process that pulls all of that data together. So in the on-prem world for SQL Server, that used to be integration services. If you're cloud-based, you're probably going to be using Azure Data Factory or you're going to be using Databricks, something like that. But you first have to understand what business process it is, what business process it is that you're trying to measure. And then what do you want to measure? How do you want to measure it? You know, how do you want to slice and dice it? And you really have to think about it in those terms, because then you're going to have to go out to your relational system and say, okay, you know, I'm trying to measure procurement. Well, how am I going to measure procurement? Well, things that are involved with procurement, you have POs, you have invoices, you have payments. In a relational system, you're probably looking at least with just those three concepts, you're probably looking at 15 to 20 tables alone. So you have to combine all of that in there, and you have to figure out how you're going to slice that data, and that's going to be your dimensions. So this is, I'm very oversimplifying the process that's involved for data modeling with this session, because it's just to kind of get you kind of thinking about it, but there's a whole lot that goes into this. And it really comes back to, what do you want to count and how do you want to count it? Because I have gone down that rabbit hole of trying to find something in a relational database, and either I'm like, 2 hours later and I still can't find it, and I have to stop and think, okay, what am I trying to count? How am I trying to count it? And then it kind of helps me refocus and figure out, okay, where does this attribute belong? Does that make sense?
Mm-hmm.
Okay. Any other questions? Take another drink here. And we still have like, what, 25 minutes? Is that right?
Yes.
Okay. All right. I don't have 25 more minutes of content. I'm just making sure.
Yes, you're good. You're doing great.
Okay. All right. Well, let's talk about snowflaking then. So snowflaking are dimensions that describe other dimensions. So remember, in that star schema, dimensions are only supposed to describe facts, but sometimes we have dimensions that describe other dimensions. So, and for me, this was, as a former DBA, this was the hardest thing, the hardest habit for me to break, because I want to normalize everything. We don't want those repeating values. And so many times I have to go, oh no, it's okay. We can repeat those values. It's all right. So in our example here, we've got our sales fact table, and then we've got our product dimension. And then we have two other dimensions. We have segment and we have category. And our product table is related to our fact or sales fact table on the product key. And our segment table is related to the product table with that segment key. And our category table is related to the product table with that category key. So here, our segment and our category dimensions are describing our product dimension. So that's an example of snowflaking. And we want to be able to denormalize this. We want to melt that snowflake in essence. So how do we go about doing that? Well, what we can do is we can take those values from our segment table, that name and that description, and we can add them to our product table. We've got that relationship with the segment key. So we can do that. We can just pop those values over there. And once we have that segment name and description in our product table, we can get rid of that segment table. We don't need it anymore. And now that we don't have a segment table, now we can get rid of the segment key because we don't need that either. Same thing with our category table. We can take those two columns, the name and the description for the category, add it to our product table. We've got them there. So now we don't need that category table anymore. And now, because we don't have a category table, we can get rid of that category key out of our product table. And just like that, no more snowflake. So like I said, the hardest habit for me to break was normalizing things, because I come from that DBA background. And really what dimensional modeling is denormalizing everything, but in a way that makes sense for your business process. So snowflakes are bad because, again, dimensions shouldn't describe other dimensions, There are a very few exceptions to that rule, but for the most part, you don't want that to happen. So snowflaking, bad. Snowflakes aren't bad. Snowflaking is bad. There we go. I want to be very PC on that. So that's how you would kind of get started building a dimensional model, or even thinking about that and how you would do that. And you have any questions on how you would get started with that? Again, I would highly recommend Kimball's book, The Warehouse Toolkit. Super, super great modeling for lots of different business processes in there. It's wonderful. Saved me many, many times. And that's all I have. That's it. I do have a couple of resource links here on my resource slide. My slide deck is available out on my website, which is sqlswimmer.com. Just go to the presentations page and look for getting started with data modeling, and you can download the slide deck there. Again, my handle on Twitter is SQL Swimmer. I am on LinkedIn. I'm going to ask, and I'm happy to connect with you, but I am going to ask that if you want to connect with me on LinkedIn, please tell me where you saw me. Being a woman in tech is hard, but being a woman in tech on the internet is even harder. So if I don't recognize your name, I'm not going to accept it unless you tell me where you saw me. So just FYI, but if you tell me where you saw me, I'm happy to connect with you. And that's it. And I love my hat.